quickly. Fine. So microprocessors are basically dependent on three things. First thing is called database, a set of parallel lines which for basically what flows inside them is the data. Next is address bus, parallel set of lines again. What flows inside is address. Control bus, again set of parallel lines, but what flows inside is the signals of the control unit. Fine. So database has a capacity by which we define the size of the processor like 8-bit, 16-bit, and by database we can actually calculate how bigger the number we can process inside. So if 2 raised to power 8 is 8-bit processor, that means 2 raised to power 8, it comes out to be 256, and if we include 0, the biggest number will be 255 in the case of 8085. But in the case of 8086, if we do the same calculation 2 raised to power 16, the biggest number will be 65536. That means by including 0, it will become 0 to 65535. Fine. But a different bus will have a different phenomena. The address bus is totally related with memory. Fine. So all the memories will have addresses. Fine. So those addresses generation, connectivity to the address, fetching the data from that addresses, that is the job of the address bus. In case of 8086, the size of the address bus is of 20-bit. In case of 8085, it was 16-bit. So 2 raised to power 16, we have seen 65536. In memory terms, we call it 64K. All right. So this is the memory we can interface. The microprocessor has the biggest lacuna. They do not have on-chip ROM. We have to interface some ROM memory from outside. So that we need address buses to be connected with the memory always. Next is with the case of 8086 2 raised to power 20, which comes out to be 1048576, which is equal to 1 mega. Fine. So that comes out to the memory which is called, how many times it is bigger than 8085? How many times it is bigger than 64K and 1M? How much is bigger than that? 16 times of 8085. 8086 is equal to, in terms of memory, you need 16 8085 microprocessors to equal to the 1M memory of 8086. See, this is how it is expanding with the capacity of processing in the 86. 85 was 8-bit, 86 is 16-bit. Bigger the number we can process, number of bits in the address bus, they are more, and the phenomena of operation is totally different. This is how the processor's speed and the performance will be measured, and it will be improved. All right, so let's get back to the features. The second point we were discussing, it is having 16-bit database. I hope all of you understood about the basics of database and the 20-bit address bus. Right. So in the processor, the body, when you see a processing body inside, there's a type of channel inside. Channel means the empty space from where the current flows. So that channel is of two types: N type, P type. N type means that if the majority flows is of N type, and if the majority flows is of P type, then it is of P type. In 8086, the channel is of N type. That means majority will be of N type, which passes through the channel, or the channel is of N type. Fine. Next we have the types of fabrication, types of 8086 on the basis of a fabrication. So 8086 on the basis of fabrication, or every IC on the basis of this number printed on them, we can understand what fabrication we have. So if it is written, if this is an IC, there are numbers written onto it. So there is a pattern to address and pattern to identify many things from the top that I'll tell you in the laboratory. Fine. So what is the thing we need to discuss right now is, if it is 8086, plainly written 8086, and if it is written 80C86, C stands for CMOS. The technology of fabrication here is CMOS, and if there is nothing in between, then it is called HMOS. HMOS means high speed MOS. MOS means metal oxide semiconductor. high speed MOS. And in this, CMOS stands for complementary MOS. Complementary MOS means complementary metal oxide semiconductor circuit. So they are two different circuits. They work totally different in a totally different manner. What we have to discuss is there is a trade-off again between them. Since it is of high speed, it draws larger amount of current when it works in a system. So it draws around 360 milliamps at 5 volt. But the system which is 8086, which has been manufactured, or sorry, fabricated by the CMOS fabrication technology, it draws only 10 milliamps at 5 volt. So now you can very well understand what trade-off what I was asking about. So this draws 360 milliamps and this draws only 10 milliamps. Now see the difference what we are having. One is having 10 milliamps and one is having 36 times greater than that. HMOS is having 36 times greater than that. If the current value is 36 times greater than this, and this is what we call high speed MOS processor, so what's going to happen? Someone who is drawing more current, how it will affect the system? A circuit which is drawing more current, how it will affect the system? Can anyone tell me? A circuit which is
So it
drawing more current, how it will affect the system? Yes, yes, yes. Somebody was speaking. Speak up, sure.
will produce.
What it will produce?
So so it will produce more heat.
Definitely.
Power.
On sorry. Speak.
So there will be more power dissipation and there will be more heat generated
Definitely,
due to
definitely,
flow.
definitely. More heat. Which formula? Which physics law are we talking right now? Someone which is related with. This is all related with physics right now. A basic formula of physics, a basic law of physics. Have you forgotten this Joule's law of heating, which was I square R, and if there is a time associated with this, time also comes. So whatever the amount of I we are having, the amount of heat which will be generated will be equivalent to square of that. Now just imagine, it is already 36 times higher. The moment I'm going to do the square of 36, how much heat will be generating? Fine. So this is the trade-off what we are having. If you are looking for a high-speed circuit which will work in a very high speed, definitely it is going to be heated. Fine. But if the circuit is not high speed, it will be more stable because it will be having less amount of heat generated inside. Okay, so always keep in mind, high speed circuits will produce more heat, which needs more cooling, more costly, bigger heat sinks, bigger techniques to pass the air and that heat. So they will be costly. Fine. And on other sides, the circuit CMOS is very good for the domestic purposes. They are pretty stable, but you may not be able to have too much of the high speed application from them. Understood? So we
Yes,
have
sir.
discussed these 2 points, CMOS and HMOS. So basic temperature range on which it can work is 32 degree Fahrenheit to 180 degree Fahrenheit, and the clock frequency is from 5, 8, 10 megahertz, because there are variants of 8086. By different variants, we were having a different frequency. So you can have a range from 5 to 10 megahertz, which can be connected with 8086. So if somebody asks you how many transistors are inside 8086, you can blindly say it contains 29,000 transistors inside the 8086. Alright, so these are the basic features of 8086 that you must know before studying 8086. Now I'm going to show you how 8086 looks like. This is your 8086. This is how it looks like, and this particular diagram that you are watching right now, I put some colors inside, though that is looking more colorful to you. So this figure which you're watching right now is called pin diagram of 8086, because there are pins on the left side and the right side. That's why it is called pin diagram of 8086, and this is very important from the point of view of examination. Fine, so everything we will be studying in this. Fine, so let's write it like this. This is your 8086. Fine. So after pin diagram, the next thing we'll be studying is the architecture of the 8086 microprocessor. This is like this, and then details what is the operational part and other things. Okay. So there is one thing we still need to gather from this pin diagram is, so what we discussed. Uh, let's start from this place only. So how many number of pins are here? Pins are like this: 1 2 3 4 5 6 7 8 9 20, then 21 to 40, and it goes always like this, anti clockwise. The fashion of counting the pins is always anti clockwise, and in many processors you will find some identification note at this point, pin number 1. They will provide you some indication, like most common indication is a hole or a circular identification, which tells us from where the pin number 1 is. Because if you do not know where pin number 1 is, the pin number 1 and pin number 21 could be same. Fine, so you need to understand first from where the pin number 1 starts. Okay, so let's start with this. So this package, the picture of this, the way it is looking at you right now, is called DIP, and DIP stands for dual inline package. In VLSI, we call this kind of package or this kind of uh, IC is DIP. DIP means it is having two lines running in the parallel, and the package is having the pins on the sides. All right. So this package is called DIP package, dual inline package. Fine. If somebody asks you 8086 is what package, you can simply say it is DIP. Okay then. So now there are few things we need to understand, like how many number of pins we are having here is, the number of pins we are having here is 40. Okay, but originally the processors were not having for this 40 number of pins. The way it was designed, initially it was having around 80 to 90 pins. All right, it was a very big circuit. Then what the designers and the researchers did, they tried reducing the structure, they tried reducing the number of pins by adopting some strategies. All right, so in this case, the way you are watching pin number 40, there are few things which are hidden inside. Fine, so let's discuss those hidden things first. It may be having various kind of signals at the same place. Like at the moment you are watching about a signal, the signals may be of two types: active low and active high. Identification is active low will always have a bar on them. Fine, active high will not be having anything. That means what? The active low signal will be active when you provide a 0 to them, and active high will become active when you provide 1 to them. So let's get back to the example. Let me show you the example. So there is a signal at pin number 33. That signal is called MN oblique MX bar. Fine. So this is a single pin by which we are taking two signals. Fine. So what happens here is MX bar will be activated when 0 will be connected to this, and MN will be connected when 1 will be applied to this. Fine. So by having a single pin, we are having two operations. It's like a two-way switch. It is giving you signal from both on 0 as well as on 1 also. So this is one type of technique they introduced at many places. You will see in this, they just combine few signals at the same time. Next strategy they used is multiplexing. Multiplexing is called, or this is the basic of time sharing phenomena. Time sharing in sense, I'll give you the practical example. What is happening in the 8086 is, in 8086 what we have just studied, the data bus is of how many bits? Can anyone tell me? Data bus is
16.
of, yes, definitely. Data
16.
bus is of 16 bit and the address bus is of 16 bits. Fine. So in together 20 plus 16, only the buses need 36 pins. Only the buses needs 36 pins, and after that we have so many signals. Those you can see on the right side from pin number 40 to pin number 21, we have so many signals. We have around 20 signals that will run, some as control signals, some as various signals. So out of 36 plus 2022, it is already 60, around 60, but the final product comes out to be 40. How come? Because the concept of multiplexing. So what the designers of 86 did, see, they took 16-bit data bus and 20 bit address bus. Fine. So they combined the 16 bits of data bus with the 16 upper 16 bits of the address bus, and this becomes multiplexed a oblique data bus. Multiplexed address oblique data bus. 16 bits of data and 16 bit of address, top 16 has been combined. So now how the nomination takes place, data bus will be nominated by D and address bus will be nominated by A. So they like first bit of data bus is D0 and the last bit is D15. In address A0 to A19. Now let's get back to the pin diagram. Here you will see the actual multiplexing, how it is taking place. Now start from pin number 1. What we see is ground. Fine. So, uh, okay, then we'll discuss about ground in next class. But let's discuss about the multiplexing first. So, from pin number 2 to pin number 16, from pin number 2 to this pin number 16, this is what we call multiplexed address oblique data bus, in which A stands for address and D stands for data. Fine. Are you getting my point? This is where the 15 pins of multiplex address and data has been there. The 16 pin is available at pin number 39 here, AD15. This is the 16th pin. It was not able to adjust here by the circuit, so they just provided it at pin number 39, which is the 16th pin of address and data multiplexed. Fine. After that multiplexing, the four remaining pins of address bus, they are here: A16, A17, A18, and A19. Fine. But they haven't left them to the designers जो थे उन्होंने उनको भी अकेला नहीं छोड़ा. You can see the pink signals here: S3, S4, S5. They are along with these address pins. There along with these address pins, and S stands for status signal. So they provided the status signals along with the rest of the address pins. So every time you will see there are a lot of things happening at the same time in the microprocessors. Many things, because we have to save the space, we have to save the concepts of semiconductor wafer. So just tell me one thing, the last thing I'm going to ask today, what is the benefit of reducing the size? Like if I say,
So,
yeah, sure, you can speak.
so speed will increase. It will be
कैसे
faster.
कैसे how it will be faster, how it will be faster, how a smaller processor can be faster? You may be right in the answer, but be specific with that.
So, so speed is inversely proportional to size.
How come this thing came? Speed is inversely proportional to size? No, I never heard that.
सर जो सिग्नल्स को डिस्टेंस ट्रेवल करनी पड़ेगी वो कम करनी पड़ेगी इस बार
Okay, that we
जब
can
स्ट्रक्चर
take.
स्मॉल करेंगे.
Okay, okay, ठीक है, एक पॉइंट पे ले सकते हो कि that thing is very small to cover. Yeah, I accept. Okay, fine, agreed. What else? Although it is not very much correct. What else? What else? Just think of the points, because that will be the question of your tutorial too. Okay, just imagine in a vice versa state. Let's what multiplexing we did. Let's break that multiplexing and take the multiplexing out. So that means this processor is having somewhere around 60 pins, and the size is like this. This is 40. So let's see, 20 more pins have been added. 40 and 20 is having a ratio of 30%. So that means it is 30% greater now. So how this 30% is going to affect the speed of 8086? Or it will become 25% actually. How this 25 to 30% will affect the performance of 8086? Just tell me that why they were so concentrated on reducing the number of pins, reducing the size of the processor.
सर क्योंकि सप्लाई अमाउंट तो उतनी रहेगी जो वोल्टेज की तो डिस्ट्रीब्यूशन और जगह ज्यादा हो जाएगा पिंस में.
No, 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 no. It's not like this. The distribution will always takes place when you want that particular pin to be activated. These pins will be activated in a sequence. Processor is a very smart circuitry. Just understand that. The circuitry inside is very smart. They know when to activate which particular pin, when to deactivate. So everything goes in a fashion. So never think about what they decided divide created inside is very weak. No, it's very complicated circuit. Think. I have already given you many things to talk about. Always think in terms of the stability first. The stability of a processor. Stability depends on how much heat is getting generated inside. Heat depends on definitely the area depends on the number of pins we have in the circuit. Slowly. Fine, so it goes with the connectivity, and everything is governed by only one thing, the flow of current in the circuit. Fine, if the circuit is bigger, definitely current is going to have a larger path. Larger path means more time is going to be spent. It means I square RT, there will be more heat. Fine, so understand that way, if the circuit is small, processors effective area is getting small, definitely less current will flow comparatively, I do not say less, comparatively less current will flow, less silicon wafer will be utilized, less amount of current, less amount of heat. Less amount of heat means more stability of processor, more stability means the better performance. Everything is interconnected. Just create your answers in an interconnected phenomenon. All right, so is this good? So I stop today's class by this note, and if there is anyone wants to ask anything, you can ask. Anything?
Sir, how can we reduce the heat produced in the microprocessor?
There are many ways to reduce the heat. Like if we talk about the latest, and these days microprocessor or sorry processors are coming with gel pads. There are gel pads coming on top of it, along with small, very small heat pad, or you can say fan over the on the microprocessor, bigger heat sinks, a very smart design of heat sinks. So these all are strategies to reduce the heat getting generated inside the microprocessor, because there is no way heat will not generate. Heat will generate if processor is working, current will flow, heat will generate. Definitely you can't avoid it. Fine, but yes, we can adopt some strategies so that heat will be dissipated by the surface of the microprocessor. So what happens with the gel pad? Gel pad takes the heat and it will absorb that. What heat sinks are connected with, they take that heat and dissipates in the air. What fans do, they provide constant air so that it cools off along with the heat sink. So there are various strategies you can adopt. Even the liquid cooling phenomena is coming. Fine, but that is not very successful in the domestic, because they have very small size and moisture remains in the circuit that can short them. All right, Dipen?
Yes, sir.
Okay, is there anything,
Excuse me,
anyone?
sir.
Sure.
Yes, sir. So yesterday we were studying low level language and machine level language. So
Mm.
sir, I have a doubt if we can translate machine level language into low level language. Is it possible?
Ideally not. Fine, but you
Sir,
still
why?
say, because the codes have been already converted. See, what we are, how we are down counting onto that high level to low level. Fine. At that moment of time, there is an intermediate code getting generated. Fine. After that, if you're already running in the already working in the low level language, the languages were not that efficient. Although they were very good in that operational stuff, but they were not very good with the those phenomena of coding, ciphering, or you provide security checks. No, the moment we convert them, they directly gets converted into the binary pattern. But if I want to convert that binary pattern back to the low level intermediate code, that is certainly not possible. Because what is getting here, understand, you are having a high level language, you are converting, translating the code first into the low level. Fine, every time you are transferring the code, it will generate a intermediate code. So that is not possible. The code with what you are having in the binary right now will be corresponding to the same code. हर बार वो एक सेम सिंबल के लिए भी नेक्स्ट कोड जनरेट करेगा. तो बाइनरी से जो आप कन्वर्ट करोगे ना, वो हमेशा उसका सेम होगा. इसकी क्या गारंटी है?
सर
समझ
जिन
गए?
प्रोसेसेस को फॉलो करके हमने मतलब मशीन लेवल लैंग्वेज में ट्रांसलेट किया, सर उसका रिवर्स करके हम क्यों नहीं जा पा रहे ऊपर? क्योंकि जैसे
इसलिए नहीं जा पा रहे हैं क्योंकि जैसे सी है, हमने बहुत सिंपल से यूज किया था, सी प्लस प्लस सी इज इक्वल टू ए प्लस बी. एक बार एक स्टेटमेंट में सी आया, उसने उसको एक कोड जनरेट कर दिया, लेट से कैपिटल ए. नेक्स्ट टाइम सेकंड 2-3 लाइन के बाद फिर से अगर सी आ जाता है, तो वो उसको एक डिफरेंट कोड दे देगा. ठीक है, बट नीचे जो बाइनरी पैटर्न चल रहा है, उस बाइनरी पैटर्न को कॉरेस्पॉन्डिंगली उसी इंटरमीडिएट कोड के अगेंस्ट डिकोड करना, दैट इज एक्चुअली वेरी इम्पॉसिबल टास्क. एंड इफ यू कुड डू दैट, there are ways. I do not say nothing is possible. There are ways we can do that, but for that you need to be very specific about the bits and bytes. आपको एक एक बिट एंड बाइट का पूरा फ्रेमवर्क दिमाग में फिट होना चाहिए, that this particular bit will be fitting for what. हो सकता है, ऐसा नहीं है कि नहीं हो सकता.
ओके सर.
हो सकता है, पॉसिबल है, बट what we are not able to do that is at very hacking kind of phenomena that we are going in terms of at those levels which are not defined in that way. तो हमें कुछ अलग से अपना एक डाउन फ्रेम और अप फ्रेम का एक कोई प्रोग्राम बनाना पड़ेगा which can correlate with that. इम्पॉसिबल वाला वर्ड मैं यूज
Yes,
नहीं
sir.
करूंगा, बट दैट इट इज इम्पॉसिबल, नहीं ऐसा नहीं हो सकता, इट्स नथिंग लाइक दैट। कंप्यूटिंग डोमेन में सब कुछ पॉसिबल है। ऑलराइट, एनीथिंग